Hi everyone, and welcome to our part 2 video for Stereocenter nomenclature. In our previous video, we went over how to name molecules using the Kohn-Ingold prelog system, doing R and S, and today we're going to go a little bit deeper and try to use that and apply it to enantiomers and diastereomers. So let's take a look at why this is important to know, why these R and S configurations are important. So I have this slide here again. This, if you remember, was in a previous video on stereoisomers. And here we have enantiomers and diastereomers again. And an important thing to remember in how they differ is their absolute configurations and how many stereocenters specifically are differing in their absolute configurations. So we're going to look at the stereocenters here and here. So this one has a stereocenter here and here, and this one has stereocenters here, here, and here, and again on the diastereomer. So when you're looking at enantiomers, the configurations are different completely. So all of the stereocenters are inverted, whereas in a molecule that's a diastereomer, when you're looking at diastereomers, you'll see that at least one of the molecules are inverted. So we have a wedge here and a wedge here, a dashed line here and a dashed line here, which is the same across the diastereomers, but they differ at one of the stereocenters. Okay, so let's take a look at an example to kind of help. Let's take a look at an example again. So here we have pseudoephedrine and ephedrine. All right, so let's take a look at an example to kind of help understand this a little bit more. So we have here, I'm not going to go through the Kohn-Ingold prelog priority rules, but I'm going to kind of assign them, and you can go ahead and verify them on your own time. But here we have chiral carbons, here and here, and here and here. And we're going to ask ourselves, are these diastereomers or enantiomers? And the best way to tell is if you look at the absolute configurations of the chiral carbons. So here we have S and R on this and this. And here we have R and R. So as you can see, this is different, but this is the same. However, not all of the stereocenters are inverted. So that being the case, these are diastereomers. If they were enantiomers, you would find that this would be an R and an S. So everything would be inverted. So let's take a look at this one. This molecule, we'll start by finding what the chiral carbon is. These are the chiral carbons. You'll see that this is inverted, and since there's only one stereocenter, all of the stereocenters are inverted. So this is considered an enantiomer. So in summary, if we had to look at this, in enantiomers, you invert all of the stereocenters. So everything that's R becomes S, everything that's S becomes R configuration. In a diastereomer, you invert at least one of the stereocenters. Not necessarily, but you invert at least one of the stereocenters, but not all of them. So if you could have, as in the case of pseudoephedrine, when S and N are here, but in the diastereomers, you see that only one of them actually inverted to an R. Okay, so that's kind of the breakdown of that. All right, so let's take a look at these molecules now and figure out which ones are diastereomers and which ones are enantiomers. So again, for diastereomers, let's start there. We're looking for only one of, or at least one of the stereocenters to be inverted, but not necessarily all of them. So we're going to tell from here that this is a diastereomer. You can also tell from here and here that these are diastereomers, since you have two S's and then one becomes an R configuration. So this is also diastereomers. And let's take a look across here. We see that there's two R configurations and two S configurations. So these are enantiomers. And similarly, we have an R and an S. However, the R on this carbon now becomes an S configuration. And this carbon, which has an S configuration, becomes an R configuration. So these are enantiomers. Okay, so hopefully you guys got some practice in there, but it's good to really understand and know how to assign the priority rules so you can apply the R and the S configurations to the molecules. Thanks for listening.